Question number 1. Explain why atmospheric pressure always decreases with increasing altitude. Atmospheric pressure always decreases because there is less atmosphere above to provide weight, which is responsible for the pressure at any point. Question number 2. What might cause the air pressure to change at the bottom of an air column? The column is heated and the air is now lighter than the surrounding air, so it rises, causing the pressure to drop at the surface. Next, why is the decrease of air pressure with increasing altitude more rapid when air is cold? It is because cold air is dense, hence the molecules crowd closer to the surface. What is considered standard sea level atmospheric pressure? It is 1013.25 MB and 650 Fahrenheit or 29.92 in Hg. How does a mercurial barometer work? Tube filled with mercury inverted and placed in a pot of mercury. Weight of air pressing down on the pot increasing the decreases, moving the mercury up or down the tube. Question number 6. How does an aneroid barometer measure atmospheric pressure? How does it differ from a mercurial? An aneroid contains a silicon cell that has a partial vacuum in it. Any changes in pressure outside of the cell cause the cell to expand or contract. And it differs from a molecular is that it does not have any liquid. Number 7. How does sea level pressure differ from station pressure? Can the two ever be the same? Sea level pressure is a pressure reduced to sea level. Station pressure is the pressure of the station at its particular elevation. To convert it to the sea level, apply an altitude correction. The two can be the same if the station altitude is 0. Next, why will Denver, Colorado always have a lower station pressure than Chicago, Illinois? It is because of an altitude of 1 mile. What are isobars? In what increment are they usually drawn on a surface weather map? Lines of equal pressure, they are drawn for every 4 MB. Isobar is a line of equal pressure and it can be drawn for every 4 MB. On an upper level map, is cold air aloft generally associated with low or high pressure? What about warm air aloft? A cold air aloft is associated with a low pressure. Warm air aloft is associated with a high pressure. What do Newton's first and second laws of motion tell us? Number 1 law is a body in a motion tends to stay in a motion. A body at rest tends to stay at rest unless acted upon by an equal and opposing force. Law number 2, force is equal to ma. What does a steep or a strong pressure gradient mean? How would it appear on a Sapper map? A steep pressure gradient means it's a big changes in the pressure over a short distance. It shows up on a surface map with the isobars drawn close together. Number 13. What is the name of the force that initially sets the air in a motion and hence causes the wind to blow? It is the PGF. Number 14. Explain why on a map closely spaced isobars or contours indicate strong winds and widely spaced isobars or contours indicate weak winds. Closely spaced isobars means a strong pressure gradient. This results in a stronger pressure gradient force and hence a stronger wind speed. Since F is equal to ma, the A will be bigger if the slope or gradient is greater. Gravity will pull it downhill faster. Number 15. What does the Coriolis force do to moving air in the northern hemisphere and southern hemisphere? In northern hemisphere, it causes the wind to veer to the right. In southern hemisphere, causes the wind to veer to the left. Explain how each of the following influences the Coriolis force in terms of wind speed and latitude. In wind speed, the stronger the wind, the greater the deflection. In altitude, 0 at the equator to a maximum at the poles. Next, why do upper level winds in the middle altitudes of both hemispheres generally blow from west to east? It is because of PGF. Number 18. What is geostrophic wind? On an upper level chart, how does it blow? Geostrophic wind is a wind blowing parallel to the isobars. What are the forces that affect the horizontal movement of air? It is affected by PGF, Coriolis, and friction if in the boundary layer. Describe how the wind blows around high-pressure areas and low-pressure areas aloft and near the surface in Northern Hemisphere and Southern Hemisphere. Aloft is parallel to isobars, NH low is counterclockwise, NH high is clockwise, SH high counterclockwise. Surface across isobars, NH low it is counterclockwise, NH high clockwise out of, SH low clockwise into, SH high counterclockwise out of. How does zonal flow differ from meridional flow? A zonal flow is a wind blowing from west to east, while meridional winds blows from north to south or along the meridians or longitude lines. If the clouds overhead are moving from north to south, would the upper level center of low pressure be to the east or west of you? With your back to the wind, the low is on the left and the high is on the right or east. On a surface map, why do surface winds tend to cross the isobars and flow from higher pressure toward lower pressure? It is because of the friction. Since there is always an upward directed pressure gradient force, why doesn't air rush off into space? It is because the vertical motion is not strong enough to exceed the escape velocity imposed by gravity. It is called hydrostatic equilibrium. List as many ways as you can of determining wind direction and speed. It can be determining by trees, flags, wet finger, or wind instrument. Below is a list of instruments. Describe how each of one is able to measure wind speed, wind direction, or both. Wind vane, direction only points into wind. Cap anemometer, speed only, and cap's spin and speed is registered. Aerovane, direction and speed, points into wind. Spinning propeller measures speeds. And the radiozone, it calculated geometrically from speed and direction of balloon. Satellite, it measures movement of clouds. Wind profiler, it measures vertical profile of wind, speeds and direction from movement of raindrops. An upper wind direction is reported as 225. From what compass direction is the wind blowing? It is blowing to southwest.